Hello lovely people, what is up? Today we are solving Leetcode problem number 2. Add two numbers. So we are given two linked lists, non-empty linked lists that represents two non-negative integers. The digits are stored in reverse order and each of their nodes contains a single digit. So the linked list, to read it the right way, we need to reverse it. So in the given example, the linked list is 2, 4, 3 and second is 5, 6, 4. So the right number that these linked lists are representing is 3, 4, 2 and 4, 6, 5 because it is stored in reverse. That is what is given in the question. And we add both the numbers after reversing it and return the sum as a linked list. And also we can assume the two numbers do not contain any leading zeros except the number 0 itself. So usually when we are adding numbers, we add from right to left. That is, we start from one's place and move up. But here, since it is reversed, we can directly start from the head. We don't need to reverse anything because usually we start in the ones place and the ones place is the head of the linked list here, and we don't need any stack implementation. So this problem has already simplified our issue. So how does this addition work? Let us take the two given example linked lists, 2, 4, 3 and 5, 6 and 4. So when we add 2 and 5, the sum is 7 and carry is 0. So the digit will be 7 and new carry will be 0. Then in the next place we have 4 and 6. Now the carry is 0 because last time the carry was 0. And then sum is 10. Since it has two digits, we just take the ones place 0 and then add the next place to carry. So new carry will be 1. In the next node of the linked list, we have 3 and 4. We saw previously we had carry 1. So carry is 1. So we add 3 plus 4 and add the carry. So sum will be 8. Digit is 8 and carry is 0. So the resultant number or the linked list will be 708. So here we introduce a dummy node to simplify the first insertion. So we don't have to add any extra if-else logic. So we use dummy node and current to signify or represent two pointers. So when we look at the coding perspective, we first create a dummy node. So this is a fake starting node. So dummy equal to list node of 0. So this helps avoid handling special cases for the first node and it makes insertion more easy and uniform. And then we initialize the current pointer that points to the dummy, which is current equal to dummy. This pointer tells us where we should insert the next node. So that is initially it will insert the first node into dummy. So and then we initialize carry. So carry equal to 0. This stores the overflow from the addition that we are going to do. And then we begin the main loop, which is while L1 or L2 or carry. This means we continue the loop till L1 has nodes or L2 has nodes or a carry is left. Then we get values from nodes. So V1 is equal to L1 dot value if L1 else 0. So if L1 exists, we take its value, else we treat it as 0. And then same for value 2. V2 is equal to L2 dot val if L2 else 0. So we do this because lists can be different length. That is the linked list that is given. For example, if L1 has 3 digits and L2 has only 2, when L2 ends, that is after the 2 digits are done, we can add a 0 to the third place so that it does not affect our addition. Now we enter the core logic. So we initialize a variable total. Total is equal to V1 plus V2 plus carry. So this is basically how we add 2 digits and then check if it has a carry and then add carry. Finally, we take the added value and then we update carry. So carry equal to total flow divided by 10. That is, integer division gives carry. So for example, if we have 11, we know that the digit will be 1 and the carry will also be 1. But how do we do this in coding? So we use integer division. If we do 11 integer divided by 10, the answer will be 1. So the answer to the flow divided value will be the carry. And then we extract the digit, which will be digit equal to total by 10. So this will give the digit that we need. So carry we do flow division, this we do mod of 10. And then we create a new node. Current.next equal to list node of digit. So this attach new node to the result list. And then we move current pointer. Current equal to current.next. So that we move forward, so next node can be added. And then we move the L1 pointer. So if L1 equal to L1.next. So if L1, and then we define L1 equal to L1.next. So this moves the next digit in list 1. So if it exists, it moves, or if it does not, it does not. So this is to avoid error. Same for L2. If L2 equal to L2.next. And then finally, outside of the loop, we return result. Return dummy.next. We don't return just dummy here because dummy is pointing to the temporary space that we created before the head of the linked list. So we are starting from the next value to the dummy so that it gives us the value of head. So as you can see, the code is running in the most optimal time possible. So that's all for today. Hope you guys enjoyed today's video. See you in the next one. Bye guys.